Yesterday we finished talking about this notion of a confidence interval being constructed in two ways. It's just an algebraic interval with a min and a max, or we can write it this way as an estimate for our population parameter plus or minus this thing called margin of error. And I will say this, occasionally you will see margin of error abbreviated as MOE, so don't let that throw you. I've had a couple of students who would get stuck on, well, what's the MOE? Well, it just stands for margin of error. And today we're going to dig into really how to interpret a confidence interval. And then tomorrow we will start working on how to do some calculations using the point estimate. And remember, this is either typically this estimate is X bar from a sample that we took of a population, or it's p hat that we took from a sample, but it could be any statistic that we draw from a sample of a population. It could be the range, it could be the min, the max, whatever makes sense in our context. But for our purposes, we're going to focus on two things. We're going to focus on tomorrow we'll talk about p hat. And then maybe tomorrow we'll talk about X bar. I doubt it. I think it'll probably take us 2 days, 1 day for p hat and 1 day for X bar. And then we'll also see that we break down this margin of error into a couple of components. The first component is what we'll call a critical value. That critical value will be dependent on what level of confidence we want to attain. Do we want 95 or 99, or is 80% or 90% confidence okay? That critical value comes from there. And then the other part of margin of error will be the standard deviation of our sampling distribution, which is what we've been calculating all along. But we'll get into that. We'll get into that in more detail tomorrow. I just kind of want to give you an overview of where we're headed. That this confidence interval boils down to some point estimate plus or minus a margin of error, and then that margin of error has two components in it. Tomorrow we'll focus on what those components are and where they come from and things like that. But today, I want us to focus on how to interpret and how to understand confidence intervals, and a similar concept is a confidence level. With that, I'm going to switch over to the notes pages here so that we can just kind of talk our way through. Again, I'll just be using notes from previous classes, simply because it's just so hard for me to write on the screen. I'm trying to find better ways, but for right now, this is what we got. So let's take a look at this first statement or case, I guess. Gallup poll, you're very familiar with presidential approval ratings, taken on August 13th, 2010, with a 95% confidence interval. Estimate the true proportion of Americans who approved the job Barack Obama was doing as president as 0.44 plus or minus 0.03. Okay, so we want to talk about the confidence interval and the confidence level. But first of all, let's let's note what we've got here. This 0.44 is a point estimator based on the sample from Gallup poll. They did not survey every American adult. They surveyed, and you remember, they surveyed, I don't know, 1,500, some reasonable number of Americans. And so of those they sampled, they got a proportion, p hat. P hat is the point estimator for the population parameter. And so for this particular sample, they got a value of 0.44, who said they approve of the job President Obama was doing on that date. And they came up with a margin of error of 0.03%. Now, you might be wondering, well, how do we know that the margin of error is 0.03%? Well, stick around. Tomorrow we'll calculate that, and it comes from it comes directly from the sample data that was taken on that day. But today our focus is just interpreting this thing called confidence interval and confidence level. Okay. So let's talk about the confidence interval first, and the way we would interpret this in context is, with 95% confidence, the interval from 0.41 to 0.47 contains the true proportion of Americans who approve of President Obama's performance on 8/13/2010. Okay, so we're going to do the calculation here. 0.44 minus 0.03 is 0.41. 0.44 plus 0.03 is 0.44 or 0.47. And so what we're saying here is that based on this sample, we, with 95% confidence, we can say that somewhere between 0.41 or 41% and 47% of Americans approve of President Obama's job performance on August 13th. We don't know where it is in that interval. All we know is that with 95% confidence, we think it's somewhere in there. The true proportion, or the true P, is somewhere in that value. Okay. Confidence interval, I think, is a little bit easier for us to grasp. Let's talk about confidence level for just a minute. Confidence level talks about, let me get rid of that. Confidence level talks about the percentage of samples. And this confidence level goes back to the graph we looked at yesterday, where we have every sample listed here, and we're literally just counting the number of samples that contain the true mean. And we see out of this list of 20 samples, one of them doesn't contain the true mean in its interval between min and max. And so 1 out of 20 is 5%, or we can say that 95% of them do in fact contain the true mean. So that's what we mean by confidence level. If we were taking a typical exam, I would be warning you about this interpretation, because this is a very common multiple choice type question, to make sure you know the difference between confidence interval and confidence level. Confidence level says about 95% of the samples of the same size taken on 8/13 will contain the true proportion of Americans who approve of President Obama's performance. Okay, so confidence level speaks to how many samples taken of that particular size, whatever it is. Let's say it was 1,500 on that day. Of those samples under the same conditions, where they're calling landlines and mobile lines, and they call back if they don't get an answer the first time. You remember those conditions. So about 95% of those samples taken with those methods would contain the true proportion of Americans who approve of the president's job performance. Confidence level doesn't really tell us where it is on a number line. Confidence level just talks about the number of samples. If we want to know what the value is on a number line, we've got to talk about confidence interval. These two go kind of hand in hand, but they are different. They are different interpretations. And quite honestly, on the open response question, you may be asked to interpret either the confidence interval or confidence level. I could very easily see that as being one of the questions that you might have to respond to. And quite honestly, it's low-hanging fruit. All you have to do is remember that confidence interval talks about the range between the min and the max, and that the true population parameter, whether it's a proportion or a mean, is contained within that interval, and then interpret it in context. And the context is this part right here. Let me make some. The context of the case is right here. It's a job approval. So this part here is kind of boilerplate with 95% confidence. The interval, which is described up here, contains the true proportion or the true mean, and then you state the context. And then for confidence level, the boilerplate is, again, pretty much the same. You begin that interpretation about whatever percent, 95%, 99%, 90, 80, whatever the percentage is. About 95% of the samples of the same size taken on that date will contain, again, and then you just add the context of the case that you're talking about. About 95% of the samples of the same size taken on this date will contain the true proportion of I don't know, blue poker chips in the bucket of red and blue. Whatever the context is, all you do is you add it after this opening statement here. So make sure you understand pretty well how these two things work together, and how they are fundamentally different. So let's take a look at, I think it's another example. Oh, before we leave this, I didn't do this on purpose, but when I started looking at this, reading through it this morning earlier, I thought, you know what? I wonder what President Trump's approval is, because so many of us remember Barack Obama as being a widely popular president. Well, for most of his term, his 8 years, his presidential approval was less than 50%. So I just went back to the Gallup poll today, and I looked it up, and President Trump's approval is 43%. So I found it interesting that as much as people seem to focus on how bad he is, not fundamentally different than where President Obama was at one point in his presidency. So I'm telling you, Gallup polls are your friend when you're trying to understand world scenarios. I just really do find it valuable. Okay, so now I'm giving you kind of a formal interpretation of confidence level and confidence intervals, and you can find this. You can find these things, these interpretations in your textbook on page 474. I think I referred to it yesterday, but that little dialog box there at the bottom of page 474 is something that you want to make sure you pay attention to and take close consideration. But basically, it's a boilerplate for your response. Approximately 95% of all samples. Okay, so if we're talking about the number of samples and we're talking confidence level of size n from this population will result in an interval that contains the population. What's the interval? We don't know. Based on the confidence level, all we know is that after repeated samples over and over and over, about 95% of them, or 90% or 99%, whatever your confidence level is or confidence value is, that percentage of samples will contain the true parameter, either the mean or the population parameter P, proportion P. Confidence interval is the min to max value that captures the actual parameter. So with the confidence interval, we can say, hey, the true proportion of people who approve of the president's performance is between value A and value B. Okay, so that's the interval. Now, some students really get confused. Confidence level and confidence intervals do not talk about probability. So as you go through here, make sure that you understand that these things do not talk about probability. Either a confidence interval is a range that contains the true parameter. Confidence level is a percentage or proportion of samples that would contain the true parameter. There is nothing about a probability. A lot of people want to say that that there's a 95% chance that our sample is going to contain the true value, and that's really not what these things tell us. Another way of understanding the confidence interval is it's a plausible range for the true population parameter. It's a reasonable set of values that will contain the true value. So either way, we want to make sure that we understand that confidence interval is not interpreted in terms of probability. But it is or could be considered a plausible range for us to understand where the true parameter lies. Okay, so now let's take a look at the conditions for inference. You'll see this, I'm certain you'll see this on your exam, probably in both questions. And you'll see a statement like, assume conditions for inference are met. If you don't see that statement, then you have to, before you calculate a confidence interval or before you start an inference calculation, which we'll talk about after confidence intervals, you have to, in your response, you have to state that these three conditions are met before you proceed to calculate. The first one is that the data comes from a random source. In other words, a well-designed random sample or experiment. And remember, from back in the day, random samples can be a simple random sample, stratified random sample, or a cluster sample. Most often, these cases are given to us from a simple random sample, but I'm guessing based on the type of questions that we may read about or you may be presented, you may have to talk about a stratified random sample or a cluster sample. Or if an experiment, you remember we talked about completely random experiments. We talked about a blocked experiments. We talked about match pairs. all of those would be considered a well-designed random sample or randomized experiment. So you're reading the case very carefully to make sure that you can conclude, okay, this data does come from a random source. Whether it's a sample or an experiment, doesn't matter, but it does need to be a random source. The second condition for inference is that our data has to be taken from a normal distribution. And so that's why we spent so much time in the last chapter making sure that our sampling distributions had this shape. If the only thing you have is a skewed distribution, then you can't construct a confidence interval. Or if the distribution is bimodal, for example, like student heights that contain both males and females mixed together. If your distribution is not normal, then you can't construct a confidence interval. So that's why it's important that we understand that what the conditions for our sampling distribution to being normally shaped are. And if it's a proportion, there were two conditions. N times P had to be greater than or equal to 10, and N times 1 minus P has to be greater than or equal to 10. So if your case is you're looking to estimate the population proportion, then you have to do this calculation if you're not told. For a sampling distribution of X bar, then that distribution is normally distributed. If the population is normal to begin with, then that's the easiest of all circumstances where you know the population is normally distributed, then you know your sampling distribution is normal. But if your population is not normal, then the central limit theorem kind of gives us a trump card to play here, as long as our sample size is large enough, greater than or equal to about 30. So the second condition for inference is that our sampling distribution is normally shaped, and we know it can be normally shaped for a proportion under these conditions, and then for a mean, it's one of these two. Either the population is normal to begin with, or the central limit theorem covers us. I remember the question we talked about yesterday. The sample size was 840. Okay, so I don't remember whether it was a proportion or whether it was a mean, but either way, with N equal to 840, the P has to be really, really small for that product not to be greater than 10. As long as N is large, or as long as the population is normally distributed, we're in good shape with the second condition. And then the third condition is what we have been referring to as the 10% condition. In other words, the observations are independent, and we can make that assumption as long as our sample is small compared to the population. So as long as our sample is less than 10% of the size of the population, then we can say, okay, independence is met. And remember, a lot of times your case won't say population is 10,000, 1,100 people, or 56,000 tests, AP exams. We often don't know. We don't often know truly what the size N is. We just know that it is that it's a big value. You remember, we would just say it's big when we compare maybe the the population of the United States or the number of students in Kentucky or the number of M&Ms produced in a particular year. You don't have to know the absolute value of that population to say it's big, and that a sample of 50 from that population certainly meets this 10% condition. So you don't always know this capital N, but you'll often be able to understand from the case that the population is big or large. And so you just have to make a statement. The population is large and our sample of 30 is small compared to that population. So independence is met. But if you're not told, so that's what I'm saying is, if you're not told in the context of the case that the conditions for inference are met, then you have to go through and prove that they are met. And based on what I understand of the way the questions are going to be worded, I could see this being a step where you have to demonstrate that it is okay to calculate a confidence interval. And again, the outline is very simple. Does the data come from a random source? Does the data come from a normal distribution, either a normal population, or we took samples and our sampling distribution is normally distributed? And then the third thing is, are our samples independent? In other words, is the 10% condition met? So this list is on page, you might want to put a sticker on page 479 of your textbook. There's a broader discussion there, but on page 49, if you've got a Post-it note or something like that, you'll want to make sure that you're very, very familiar with these three conditions, because anytime you construct a confidence interval or we do an inference problem, then you need to make sure these things are met. Okay. And so I think that's as far as I want to go today. Yeah. We'll pick up with calculating confidence intervals tomorrow. But before we leave, I do want us to cover a couple of questions in the back of our textbook. So flip over to page 482 in the textbook, and we will take a look at question number 9. Again, it helps us gain an understanding of what the confidence level is. In other words, what percentage of samples actually contain the population parameter. So let's look at question 9. We've got a figure below of 25 simple random samples from a normal population. So we know our sampling distribution is normal. And we want to construct a confidence interval for each sample. Which confidence level was used? Okay, so if we look at that, and we notice that some of the samples are kind of highlighted in red, and those do not contain the true population mean. So if you count that, there are 1, 2, 3, 4 of those. So that means 21 of the 25 do in fact contain the true population parameter. If we do that calculation, 21 out of 25 is 84%. And so the closest choice we have is 80% confidence. Okay, and so it points out a couple of things. First of all, if we calculate the number of samples and we come up with this proportionate 84%, we could say it was with 84% confidence, so that our confidence level is 84%, but we can't say it's 90 because it's not. We can say it's 80, 84% is greater than 80, but 84% is not greater than 90. So we have to stick with a level that is less than what we would actually calculate. So again, if you count up the number of samples that do contain the true mean, then you would get 21 out of 25 or 84%, which says our confidence level is roughly 80%. Okay. So that's question number 9. I want us to talk about question number 11. And from there, we'll take a couple of examples for you to work on after class here. So question 11 is based on a New York Times CBS poll. Do you favor an amendment to the Constitution that would permit organized prayer in public schools? And it doesn't say when this was taken. It just says September 13th to 18th. I don't know what year, but anyway, so 66% of the sample answered yes. The article describing the poll says it's based on telephone interviews conducted from the 13th to the 18th of September with 1,664 adults around the United States except Alaska and Hawaii. Telephone numbers were formed by random digits. And this is, you remember this methodology from looking at the Gallup poll. And so the article gives the margin of error for a 95% confidence level as plus or minus 3%. So given that case, or given that example, explain what the margin of error means to someone who knows little about statistics. Okay, so I love the way they characterize this. Explain it to someone who knows little about statistics. Frequently, I'll talk to people and I'll say, you know what? Imagine you have a little brother or sister in kindergarten and they were asking you, hey, what are you doing? What are you working on? How would you describe this case or this topic to someone who's in kindergarten so that they can understand? So you have to use simple terms and break it down without using a lot of complicated language. So in this case, what we would say, the margin of error means that is, if we took this sample in the same way, using that methodology over and over and over again, the sample proportion that we achieved would be within plus or minus 3% of the true value, 95% of this in 95% of the samples. So let me say that again. It's a lot of words, but it's still kind of a boilerplate kind of response. Okay, so the margin of error means in this case that if we were to use the above methodology over and over and over, the true proportion of people who said yes, that they've favored a change to the Constitution permitting prayer in public schools, the true population proportion would be contained in our sample interval of plus or minus 3% in about 95% of the samples. Okay. So now we want to state and interpret the 95% confidence interval. Well, our margin of error is plus or minus 3 percentage points, and our p-hat was 66%. So our confidence interval would be 66 minus 3%, which is 63, and 66 plus, which would be 69. So our confidence interval, we would interpret this way. We are 95% confident that the interval from 0.63 to 0.69 contains or captures the true proportion of Americans who believe that there should be an amendment to the Constitution permitting prayer in schools. That would be our interpretation. Notice that I started off with the same template with 95% confidence, the interval 0.63 to 0.69. That is always the same. That example is always the same. And then after I get that interval, I talk about the context. And the context here is what percentage of people approve or would vote for a constitutional amendment to prevent prayer in schools. Okay, and now we want to interpret the confidence level. And the confidence level is simply this: if we were to repeat this sampling procedure many, many times, 95% of the confidence intervals that we calculated would contain the true population proportion. Okay, so you can go back. You can go back to that dialog box on page 474, and basically take that boilerplate and then just massage it or edit it for the case here of prayer in school. Okay. Just so that you can practice this, I want you to do today or tonight question number 12 about losing weight. Again, it's basically the same process that we went through in question 11. So it should be pretty familiar to you. Don't be overly creative. Don't feel like this is a writing assignment for Mr. Bailey where you have to come up with new literature. Take those templates on page 474 and then just massage them to represent the particular case that we're talking about. Tomorrow when we get back together, we'll talk about calculating a confidence interval. We'll talk about what does this margin of error mean a little bit more in depth. And so it'll be a little bit more quantitative tomorrow. Any questions before I sign off here? Okay. All right. Well, I'll see you tomorrow at 1. I'll get this posted. I apologize for not posting this till later last night, but I had some technical difficulties, and plus it was a beautiful day, so I spent some time outside in my garden. But anyway, I'll try to get this posted a little more promptly, and so you're going to be taking a look at question number 12 on page 482. Guys, we'll see you tomorrow at 1. Y'all have a great rest of the day.